Hello students, in this video we are going to explain the meaning of remarkable identities. So let's start with the first remarkable identity, a plus b squared. Here we have this binomial a plus b. We need to find its square. So here it's in fact a plus b into a plus b, a binomial multiplied by itself. Let's expand it and see what we will obtain. So here we have the product of two factors. It's the factorized form. Let's expand it. So here we need to multiply a by a, then a by positive b. We obtain a into a. Now we write plus a into b. Then we write plus. Then we need to multiply b by a, then b by b. So positive b times a, then positive b times b. We obtain b into b, b into a, plus b into b. Since they are all positive, so here we don't have to write the sign. Equals a times a, it's a squared, plus a times b, it's ab, plus here ba, b times a is ba. Here let's write it in alphabetical order. We can write ab plus b times b, it's b squared, equals a, b, and ab are two like terms. 1ab plus 1ab equals 2ab, and we obtain a squared plus 2ab plus b squared. This is the expanded form of a plus b squared. From now on, we can memorize it and use it immediately. Now the second remarkable identity, a minus b squared, it's equal to a minus b into a minus b. We multiply a minus b by itself because we have its square. So let's expand it. Equals, here we multiply a by a, then a by negative b. We obtain a into a plus a into negative b. We write plus, then we need to multiply negative b by a, then negative b by negative b. We obtain negative b into a. Now we write plus negative b into negative b. Since they are negative, we write them between parentheses. Equals a times a, it's a squared, plus a times negative b, it's negative ab, plus negative b times a, it's negative ba. Let's write it in alphabetical order. We obtain negative ab, plus negative b times negative b, it's positive b squared. So we write b squared. Equals, here we have these two like terms, negative ab and negative ab. It means negative 1ab, negative 1ab, we obtain negative 2ab. And in the end, the expanded form is a squared minus 2ab plus b squared. This is the expanded form of a minus b squared, and we can memorize it and use it later on instead of making all this work. Now the last remarkable identity, a plus b into a minus b, it's the same as a minus b into a plus b. Here also we have the product of two binomials. Let's expand it and see what we will obtain. So it's equal to a times a, then we multiply a times positive b. We obtain a into a, we write plus, then a into positive b into b. Then we write plus. Now we multiply negative b by a, then negative b by positive b. We obtain negative b into a, we write plus negative b into b, equals a times a equals a squared, plus a times b, it's ab. We write plus negative b times a, it's negative ba. Let's write it in alphabetical order. We obtain negative ab, plus negative b times b, it's negative b squared, equals, here we have AB and negative AB are two like terms. Here, if you notice, 1AB and negative 1AB, their coefficients are opposite numbers, so their sum is 0. What remains is a squared minus b squared. This is the expanded form of a plus b into a minus b, or of a minus b into a plus b. They both have the same expanded form. Now let's rewrite these remarkable identities that we need to memorize. A plus b into a plus b is the same as a plus b squared. It's equal to a squared plus 2ab plus b squared. The second remarkable identity, a minus b into a minus b, we are multiplying a minus b by itself twice, so it's equal to a minus b squared. It's equal to a squared minus 2ab plus b squared. So here we don't put the minus here before b squared. No, it's minus 2ab. This is the difference between the first and the second remarkable identity. And the third one, a plus b into a minus b, it's equal to a minus b into a plus b. They both have the same expanded form, which is equal to a squared minus b squared. Here, all these expressions circled in red are the factorized form, and these expressions circled in green represent the expanded form. So example, expand the following expressions using the remarkable identities. Example 1, x plus 3 squared. This expanded form is similar to the first remarkable identity, a plus b squared. It's the same as a plus b into a plus b. It's the same as x plus 3 into x plus 3. Here we have a is equal to x and b is equal to 3. So to expand this expression, we don't have to do the four products. Now we can use this result. Here we have a squared plus 2ab plus b squared. This is the expanded form. And in order to memorize it, we can memorize this poem, small poem, that says we write parenthesis squared plus 2 parenthesis plus parenthesis squared. And the first parenthesis squared, inside it we place a, which here is x. So we place x here. And in the last parenthesis squared, in the second one, we place b, which here is 3. We write 3 here. And inside these two parentheses, we write a, b. It means x, then 3. We obtain x squared plus 2 into x into 3 plus 3 squared. Now let's reduce these terms. X squared is in fact x exponent 2 plus 2 times x times 3. It's 2 times 3 is 6x plus 3x squared is 9, and x squared plus 6x plus 9 is the expanded form of x plus 3 squared. Example 2, 2m minus 4 squared. It's the same as the second remarkable identity, a minus b squared, where a is equal to 2m and b is equal to 4. Not negative 4, it's 4. It's the same as a minus b into a minus b, 2m minus 4 into 2m minus 4. So if you have these two expressions, we can expand them using the same result that we proved in the previous slide. Now, here we should also memorize a poem, but the same poem as here, but the difference here is that we have negative 2ab instead of plus 2ab. So we write parenthesis squared minus 2 parenthesis plus parenthesis squared. So here a is 2m, so inside these parentheses we write 2m, and b is 4, so we write 4 inside the second parenthesis squared, and here we write 2ab, negative 2ab, we write 2m into 4. And 2m squared minus 2 into 2m into 4 plus 4 squared is the expanded form. Let's reduce it. Here 2m squared, here be careful, the square we need to spread it to the 2 and to m. 2 squared is 4 and m squared is m squared, so we obtain 4m squared. So we don't write 2m squared, it's wrong, be careful. Negative 2 times 4, it's 16, negative 16m, and 4 squared is 16 plus 16, and this is the expanded form of 2m minus 4 squared. Now third example, 1 plus 5n into 1 minus 5n. This is the same as the third remarkable identity, a minus b into a plus b. It's the same as 1 minus 5n into 1 plus 5n. They both have the same expanded form that we need to memorize. Here, a is equal to 1 and b is equal to 5n, not negative 5n, it's 5n. Now, the result is a squared minus b squared. So, what is the poem that we need to memorize here? Here it's easy. It's parenthesis squared minus parenthesis squared. So, we write parenthesis squared minus parenthesis squared. Then we fill inside the parentheses by a and by b. So, a is 1. We write 1 here. And b, it's 5n. So, we write 5n here. Equals 1 squared, it's 1. We copy the minus. 5n squared, so here be careful. We spread the square. 5 squared, it's 25. And n squared, it's n exponent 2. We obtain 25n squared. And 1 minus 25n squared is the expanded form of 1 plus 5n into 1 minus 5n, or 1 minus 5n into 1 plus 5n. They both have the same expanded form. Now, example 3, 31 squared. Here, instead of doing 31 times 31 and set up on a scratch paper, we can use the remarkable identity here. We can write here a 31 in the form of 30 plus 1 squared. It's the same as the first remarkable identity. It's 30 plus 1 into 30 plus 1. So now let's write the poem, parenthesis squared plus 2 parenthesis parenthesis plus parenthesis squared. In this example, a is equal to 30. So between the first parenthesis squared, we write 30. And b is equal to 1. So here we write 1 squared. And inside this parenthesis, we write 2 into 30 into 1, and 2 into a into b. Equals 30 squared, 30 times 30, it's 900. Plus 2 times 30 times 1, it's 60, and 1 squared, it's 1. Now let's add them. 900 plus 60 plus 1, it's equal to 961. Example 5, 29 squared. 29 is equal to 30 minus 1, so we can write 30 minus 1 squared. It's equal to 30 minus 1 into 30 minus 1. So here we will use the second remarkable identity. Here we write the poem first, parenthesis squared, here minus 2 parenthesis parenthesis plus parenthesis squared. So the minus is written before the 2. Here a is equal to 30 and b is equal to 1. We write them between the parenthesis squared. Then we write negative 2 into 30 into 1. Now we calculate 30 squared, it's 900 minus 60 plus 1. 900 minus 60, it's 840 plus 1, it's 841. And the last example, 31 times 29. Here we notice that 31 is 30 plus 1 and 29 is 30 minus 1. It's similar to the third remarkable identity, a plus b into a minus b. And this is also equal to 30 minus 1 into 30 plus 1. But we don't have to write it. Now let's write the poem. It's a squared minus b squared. It's parenthesis squared minus parenthesis squared. In the first parenthesis, we write a. Here a is 30. We write 30. And between the second parenthesis squared, we write b. b here, it's 1. So it's always, we always write the positive numbers here, 30 and 1. We don't write negative 1, so be careful. The minus here is between the parentheses squared. Equals 30 squared is 900, minus 1 squared is 1. 900 minus 1 it's equal to 899. So this is the end of this video. Review the examples as many times as needed until the concept is fully understood, and thank you for watching.